Okay, we've got a quick video here to show you how to conduct a repeated measures one-way ANOVA. I've got some data here that I've described in the assignment for non-SPSS 3. You are welcome to do an independent samples ANOVA, but several people have expressed interest in a repeated measures ANOVA. So the introductory lesson I gave for JASP was independent samples. This is dependent. All right, so I've got a set of movies that are trilogies or have more than 3 even. Rocky has 6. I think Men in Black has 4. What I'm going to do is take a look at how each franchise changed across 3 levels, the first, second, and third, because it's the same characters each time. I'm going to call that a dependent or repeated measures ANOVA. So go right there. All right, now notice I have the film names in there. I don't actually need that at all. That was just something I added. So counting up, I got 1, 2, 3. I got 3 levels. Over here it says repeated measures factors. This is a 1-factor ANOVA. So I need to make sure I have 3 levels. So I'm going to click that right there. And I'm just going to type in first, second, and third. Okay, and what that does is that opens up these cells down here in the window that says repeated measures cells. First, second, third. Okay. So that has produced the source table here. I see that my test has an F with 2, 10 degrees of freedom, has an F of 7.397, and a p-value of 0.011. Because that's less than alpha, I'm going to reject the null hypothesis and say that the tomato meter ratings on Rotten Tomato, where I got my ratings, do change at some point. I don't know where they change, so I'm going to do a post hoc test. And my post hoc test will be for factor 1. And I'm going to use the Sheffe test, because that's the one we talked about in class. And over here, this Sheffe test should be telling me, it doesn't give me a p-value. Oh, wait, okay. There we go. Sorry, I'm doing a repeated measures test. That's why I can't do Tukey or Sheffe. Sorry, had a little lapse there. Home is the correct one. So this shows the post hoc tests first compared to the second. That is not quite significantly different. First compared to third, 0.05, we'll call that significant. Second compared to third, not significant. All right, so even though we got a statistically significant result here, it looks like the real difference is between the first and the third, and that is right on the cusp of significant. So first to second isn't a significant change, and second to third isn't as change, but by the time you go from first to third, you have had a significant change. All right, one other thing to look at, descriptive plots. That can be very useful. So I'm going to move that over here and ask for error bars, so you can see how it decreases over time. And then one last thing that I would want is an effect size, and that's up here under post hoc tests. Oh wait, that's the effect size for the post hoc test. Okay, Under additional options, descriptive statistics will give you your means and standard deviations, and estimate of effect size. You can use eta squared. And that should be back up in the source table up at the top right there. All right. So that's how you do it. I'm going to put this in a PowerPoint slide where I can also point a few things out. And that should help you conduct the test as well, especially the part where you're making sense of what the output shows.